Welcome to The Explainer. Today, we're taking a fascinating, really multi-layered journey into a disease that has quite literally shaped human history and, believe it or not, continues to challenge modern medicine. We're talking about yellow fever. We're going to trace the path of this virus from its wild ecological roots deep in the rainforest straight into the absolute high-stakes environment of the intensive care unit. And finally, zoom all the way out to see how global health policy attempts to keep the whole thing contained. So think about this for a second. How exactly does a simple, everyday mosquito bite lead to complex, catastrophic organ failure? It's an incredibly alarming biological escalation. We're talking about a microscopic flavivirus transmitted by a tiny insect out in the wild that somehow manages to transform into a life-threatening medical emergency, one that's fully capable of shutting down the human body's most vital systems. Well, to really grasp the stakes here, we need to look at a pretty chilling number, 56.5%. That is the 30-day mortality rate found in a recent real-world study of severe yellow fever patients admitted to an ICU down in Brazil. Basically, more than half of these patients didn't survive a month past their admission. It's a coin flip. To understand why this virus is just so lethal, we really have to start right at the source. All right, Section 1, Cycles of Transmission. Out in the wild, the virus essentially relies on 3 distinct cycles. It's like a giant ecological puzzle. On the far left, in the jungle cycle, the virus just bounces back and forth between non-human primates and forest-dwelling mosquitoes. Humans only really get infected here if they wander into that specific territory. But on the right, in the urban cycle, a very specific type of mosquito transmits the virus strictly between humans in crowded city environments. And right in the middle, specifically over in Africa, we see an intermediate or sylvatic cycle that kind of blends the two together in rural savanna areas. Now, what really drives these cycles are the specific mosquitoes involved. In the jungle, the primary vectors are species like Haemogogus and Sabathes in South America, and Aedes africanus in Africa. These bugs live high up in the forest canopy and mainly feed on monkeys. But the urban vector? That's Aedes aegypti. This is what we call a peridomestic mosquito. Basically, it loves to live right next to us, breeding in our cities and feeding on our blood, which is exactly what triggers those explosive, terrifying urban outbreaks. Moving into Section 2, the infection period. The timeline of this infection moves ridiculously fast. At day 0, the mosquito bites. Immediately, the virus starts quietly replicating in your local lymph nodes. Then, you've got a super short incubation period, just 3 to 6 days, where the patient usually feels perfectly fine. But right after that, bam, we hit the period of infection, also known as viremia, which lasts about 3 to 5 days. During this tight window, the virus aggressively floods out of the lymph nodes into the bloodstream and makes a beeline for your major organs. And when that viremic phase hits, it hits like a freight train. Patients experience a sudden, brutal onset of acute symptoms. Their temperature spikes to around 39 degrees Celsius. They're slammed with a severe headache, just profound exhaustion, photophobia, which is the sharp, painful sensitivity to light, plus intense backaches, muscle pain, nausea, and vomiting. The massive takeaway here is that during these few days, the patient's blood is highly infectious, and the direct viral damage to their cells is officially underway. Which brings us to Section 3, predicting severe outcomes. So, when things go south and patients crash, they're rushed to the ICU with severe organ failure, and doctors need answers fast. A recent study used simple bedside ultrasound on 46 confirmed yellow fever patients and discovered some highly reproducible and highly alarming abnormalities. Look at this data. Over 80% of them had massive thickening of their gallbladder walls. Nearly 72% showed increased renal cortex echogenicity, meaning their kidneys were reflecting abnormal amounts of sound waves, and over 65% showed similar increased echogenicity right in their liver parenchyma. If we look closely at the bright areas on these actual liver ultrasound scans, that brightness indicates that increased liver echogenicity, and that correlates directly with acute viral damage and potentially fatty deposition, or steatosis, caused by the infection. You can also spot the darker areas pointing to intra-abdominal free fluid, or ascites. Basically, the virus is systematically breaking down the liver's ability to function. But honestly, the most glaring red flag is right here in the kidney ultrasound. See how the outer layer of the kidney is showing up abnormally bright compared to the surrounding tissue? That's the increased renal cortex echogenicity. In the absolute chaos of an intensive care unit, this specific visual acts as a powerful immediate warning sign that the patient is suffering from severe acute kidney injury, driven directly by the virus. And why does that bright kidney matter so much? Because of this number right here. 10.89. Researchers found that if an ICU patient exhibited that increased renal hyperechogenicity, they had an odds ratio of 10.89 for early death. To put that into perspective, patients with those bright kidneys on their ultrasound were nearly 11 times more likely to die within 30 days. It is a massive, independent predictor of a fatal outcome. And the blood work absolutely backs up what we're seeing on the screen. The numbers are frankly staggering. The average AST, which is a key liver enzyme, was 5,319 units per liter. For context, a normal level is usually under 40. Total bilirubin was at 6.2, pointing to massive liver dysfunction and jaundice. And creatinine, a huge marker for kidney failure, was up at 4.3. So the bedside ultrasound wasn't just taking pretty pictures. It was perfectly accurately reflecting the massive tissue destruction happening down at the cellular level. All right, shifting gears to Section 4, vaccination and global rules. So, how do we fight back on a global scale against such an immense biological threat? Enter the World Health Organization. The official World Health Assembly resolution on the international health regulations literally acts as international law. It's designed to stop that scary urban cycle of transmission from sparking a global pandemic through international travel. The WHO basically boiled down a mountain of science into Annex 7, which lays out 3 incredibly straightforward steps for international travelers. Step 1. You get just one single vaccine dose. Step 2, full protection against the infection kicks in exactly 10 days after you get the shot. And Step 3, which is for sure the most liberating part, your vaccination certificate is officially valid for your entire life. Actually, I want to pause here and really highlight this because it busts a very common myth. The exact text from the WHO clearly concludes that a single dose of yellow fever vaccine is sufficient to confer sustained immunity and lifelong protection against yellow fever disease, and that a booster dose of yellow fever vaccine is not needed. No way around it, it's a phenomenal medical achievement, one and done, literally for life. So, what does this all mean for us going forward? We've traced the complex ecology of the rainforest. We've seen the devastating organ failure visible on a simple ICU ultrasound screen, and we've looked at the decisive global policy that keeps us safe. It really begs the question, could combining accessible, low-cost medical ingenuity like bedside ultrasound, paired with highly effective, standardized global vaccine policies, be the ultimate blueprint for managing other re-emerging ancient diseases? It's a pretty powerful thought to leave you with. Thank you so much for joining me in this explainer, and keep learning.